Okay, we're going to start talking about trigonometry and angles and their measures. So on section 4.1, we start off talking about a degree is a unit of measurement which is equal to 1 over 360th of a part of a circle, and we represent that with this circle that looks like it's in our exponent. And you should be familiar with that because you've worked with degrees before in geometry and algebra 2. But one thing you might not have seen before is taking this degree and putting it into degrees, minutes, seconds. That's what DMS here stands for, is degrees, minutes, seconds. And this is another way of saying this that is used in navigation to be a little bit more precise than having just a decimal here. And so it's the idea that in a degree there are 60 minutes, and in a degree there are 3,600 seconds. Okay, and so in this minute there would be 60 seconds. And so that's very similar to what we have going on with time, right? Right. All right, so we're going to convert this into degrees, minutes, seconds. And so the 99 part is going to stay the same. It'll be 99 degrees. But we need to take the fractional part, the 0.37, and convert it into minutes, and then we'll convert that into seconds. So I'm going to times by 60. Okay, 0.37 times 60 is 22.2. So if it hadn't given us a decimal here at the end, then we would actually be done. Okay, if it had just said 22 and stopped, that would be all that we would need. But we have to keep going because this 0.2 is representing what our seconds are. So we have 99 degrees, we have 22 minutes. We're going to take that 0.2 and we're going to times by 60 again, because the 0.2 is 0.2 minutes, and I want to know how many seconds that is. So 0.2 times 60 is 12. So down here in my answer, I put that as 12 seconds. And that would be my answer if I'm converting from degrees to degrees, minutes, seconds. If I'm going the other way over here, I have 48 degrees, 30 minutes, and 36 seconds, and I want to convert this to the decimal. In some ways, this is easier, at least to think about, because you have 48 basically whole degrees, plus your minutes are out of 60, and your seconds are out of 3,600. Okay, because we want to know what the comparison is to degrees. So that's why we have 60 for minutes and 3,600 for seconds. So I would add these together. I'm using my calculator to do that, although this one would probably be not too terrible to try to do without a calculator. And I get 48.51 degrees. Okay, now there's a button somewhere in your calculator that lets you convert between these, but for now I would really like for you to go ahead and give this a try on converting back and forth between them by hand. The next thing it talks about is radians. That basically, degrees are kind of completely random. Like, why in the world would we divide a circle up into 360 parts? Who came up with that? Well, because of that, in more recent years, meaning like only 100 or 200 years as opposed to thousands of years, we've come up with this idea of radians that actually makes the math part of trig a lot easier. And so for the most part, we're going to be using radians, not degrees. But we're going to look at how do I convert between the two. And so it turns out that for every 180 degrees I have pi radians. Okay, for every 180 degrees I have pi radians. Okay, and that's because half of a circle is 180 degrees, and half of a circle, if I think about the circumference of a circle, if I have a radius of 1, half of that circle would be pi. So here's what we're going to do is if I have 90 degrees and I want to convert that to radians, I'm going to put degrees on bottom to cancel out my degrees. I'm going to put pi on top, and that's going to give me radians. So 90 over 180 will become 1/2. So this is really pi over 2. Okay, and then you can write radians out to the side here, but basically we assume if there's no unit that we're talking about radians. Okay, so I wouldn't bother putting radians on stuff that you're converting to radians. So they can give you things like 11.83 that don't convert quite as nicely. And so what you would do here is use your calculator. Like take 11.83 times it by pi, and then divide it by 180 and see what you get. 1.83 times pi divided by 180 is a nice long decimal. Let's round it to 3.206. And that's radians. And again, if I don't put anything, that tells me it is in radians, but if you just wanted to make sure the whole world knows that this is in radians now, you'd write radians, or you could call it rads, and that's the same thing. Go the other way, we flip our conversion, that we want to cancel out this pi, and we want to add into our conversion the idea that we have degrees. So the pi's cancel out, and I end up with 180 over 60, which is 30 degrees. Okay, and the degrees here tells me it's in degrees. Now, the second one too, you might think, oh, that's actually in degrees, but there's not a degree symbol, which means it is in fact in radians. So we're going to times by 180 over pi, and we're going to have to use our calculator to do this, because I know that 2 times 180 is 360, but what is that if I divide it by pi? It is 114.59. And this is degrees. So that would be my answer. Hey, one thing that we've got now is Arclinks that we can talk about, which is talking about if I have a circle and I kind of cut out a piece of that circle, like a pizza, then this part right here on my circle is labeled S. This is my Arclinks. My radius is what a normal radius is, and my angle is that angle inside. And so instead of talking about in degrees or radians, how long is this, we're talking about like in inches or in centimeters, how far is it? So they're going to give us some problems where they have a missing piece, like in this one it's S, and they give us 2 parts and they want us to convert it. There's 2 different formulas. One is for radian measure, which you use when you're in radians. The other is for degrees, which you use when you're in degrees. So on this one, I'm looking for S. I know that my radius is 2 inches, and my angle is 25 radians. So 2 times 25, well, that's 50. My arc length is 50 inches. Okay, then let's look at the arc length when I have a degree measure. Now this is why radians are so nice. Look how much more complicated this is, because they're giving us it in degrees instead of radians, but that's okay. We'll persevere and get through it. S is 40 centimeters. This pi on top is pi. R is what I'm looking for. My angle is 20, and this is over 180. And I guess there should be degrees there, because that's 180 degrees. All right, so to solve this, we need to figure out, well, what is all this stuff that's beside R? I would have 40 centimeters equals 20 pi over 180. Okay, so I have 0.349 R. Now, just because I wrote that down, that's just so you can see what I got. I got a much longer decimal. I'm going to divide on both sides, and since I have my calculator here, and I have this without the rounding in it, I'm going to actually do 40 divided by my answer, so I don't have any rounding error, and this is 114.59. and it's my radius, and so I end up with centimeters. So that would be my answer. The next thing it talks about is using angular speed. That basically there's a difference between speed and like revolutions per minute. Like if you have a wheel and it goes so many revolutions in a minute, and if I want to talk about miles per hour. And so basically all we're doing is converting between the two things, using the fact that I know that if I have one revolution, that equals basically the circumference of whatever is being revolved, so 2 pi r. Okay, so in this particular problem, it says Albert's truck has wheels 36 inches in diameter. If they're rotating at 630 revolutions per minute, find the truck's speed in miles per hour. So we have, starting off, 630 revolutions over 1 minute. And the way converting works is that I want to basically get rid of the two things I have and end up with miles per hour. Well, the minutes is easy. There are 60 minutes in 1 hour. And so that'll cancel out my minutes, and I'll end up with an hour. The revolutions are what takes a little bit more work. So in 1 revolution, I'm going 2 pi r, which my radius in this case comes from my diameter. The diameter is 36, which means that the radius is 18. Okay? And when I do this, this ends up being in inches, right? Because that's what my radius was in inches. Well, I need to get to miles. So from inches, there are 12 inches in a foot, and there are 5,280 feet in a mile. And so if I put all this together, I'm going to end up with the correct units. So on top, I have 630 times 60 times 2 pi times 18. That's all on top. And then I'm going to divide that by 12 times 5280. So whenever I divided, put that in parentheses, the 12 times 5280. And you should too. So this gives me 67.47 miles per hour, which we can say miles per hour is mph. So it's just a matter of converting between the things on a problem like that. One thing it introduces is the idea of a nautical mile, that basically if I am thinking about, the Earth, and then we've got like lines on the Earth to represent like our, let's see, this would be our latitude, longitude, whichever, that between those, if I go 1 minute, so not a degree, but if I go 1 minute between my lines of latitude or longitude, that is equal to what's called a nautical mile. Okay, so we've got regular miles, which are called statute miles. We've got nautical miles, which have to do with because if you're out in the middle of the sea, what you care about is where you are, latitude and longitudinally. Okay, so this is what we would use if they give us problems and we need to convert. We would use these two measurements. The last thing it talks about in this section is the idea of bearings. And so this is basically supposed to look like a compass. And if I am talking about up here at the top, I'm talking about north. To the right, I have east. At the bottom, I have south. On the left, I have west. And then we also have things like northeast and southeast and southwest and northwest. But besides that, we also have things like north, northeast, and east, northeast, and east, southeast, and south, southeast, and we can keep going. There's a picture of this in the book on on one of the problems we're doing, page 357, that it goes around. And basically, if you're talking about bearings, then you're saying if this is 0 degrees at north and I go to the right, how many degrees? So like at north-northeast, to figure out what degree this is at, I'd say, well, I know that to get to east is 90 degrees because this is a right angle. So to get all the way over here is 90. Halfway to northeast would be 45. And so halfway in between that to get north-northeast, that would be 22.5. So it's going to ask us some questions on this section about what degrees, what bearings you have if you're at a certain direction, like south, southeast, or west, or whatever. And this is, with bearings, this is the only time where we talk about the angle starting at the top and then going right. And so after this, in other sections, we'll talk about what a trigonometry type angle, basically, as opposed to a bearing. But you'd use bearings in navigation again. So that's section 4.1.